Hi there, welcome to part 2 of this series. So this video we're going to have a look at a sine graph and sketching that. So we've got the graph for take 2 sine of 3x between x values of minus a half and, minus pi on 2 and 3 pi on 2. Now just like before, we need to get some information so we are able to sketch this. The first one to look for is our amplitude. So amplitude is just the multiplier for our trig function. In this case, it's 2. We don't really need to worry about the negative sign because our amplitude just determines how far up and down we oscillate. Next information is our period. So our period is found by 2 pi over n. Oops, over n, and the n is our multiplier next to our x value. So in this case, we have 2 pi over 3. So that means for 2 pi thirds, now it's 2/3 of pi, we're going to have one full oscillation. And the equilibrium point, okay, this just determines if we've moved it up or down. In this case, we've got it's been moved up +4. So we can now look at our oscillations. So from +4, it oscillates an additional 2, and it goes down from 4, it goes down 2. So it oscillates between 2 and 6, which is our range. Because we go from 2 to 6, there is no x-intercepts. Okay, doesn't go below +2. Now, from our period, we've got 2 pi on 3, and we know that we're oscillating between minus a half pi and 3 pi on 2. So when we draw our graph, go down here. So we go from minus a half up to 0 and then to 3 pi on 2. So the total distance is between minus pi on 2 and 3 pi on 2. So we get 2 pi. So it has a total distance or total domain of 2 pi, whereas our period oscillates 2 pi on 3. So that means we need to divide it into thirds to work out. So we're going to have 3 cycles within that domain. So our period is 2 pi on 3. And we have 4 1, 2, 3, 4 bits of the graph that we can divide it up into. So if we divide 2 pi on 3 into 4 different bits. We'll give a scale of pi on 6. So each of this bit here is going to be pi on 6. Which means from minus pi on 2 to 0, we get minus pi on 6, minus 2 pi on 6, and that would be minus 3 pi on 6, but it evaluates to minus pi on 2. So here's 1, 2, 3, and we can do split this up into sixths as well. This would be 3 pi on 6. And we want, sorry, I didn't put that in the right spot. We want 3 pi on 2. So that's going to be up to 9 pi on 6, which is the same as 3 pi on 2. So we go from minus a half to 3 halves. And then from here we get our oscillations. So we have an equilibrium point at 4. As a dotted line. And range, our range goes from 2, so about there, up to there. And then we have our cycles. So our first one at minus a half, we've got the cos function, which looks like this. So it means we're going to start at 6. And for each sixth, we get a quarter of that shape. So there's our first bit. Here's our second, which will end up down at the turning minimum point there. Here's the next bit. And then up again. So there's one oscillation. Now this pattern continues, and we're going to have 3 of those in total. So for each sixth along the x-axis, we're going to have that quarter of the shape. So just filling in those. And there we go. So we've got 1, 2, 3 oscillations, which we determined from our period, and we go up between 2 and 6, which is our range, and obviously there's no x-intercepts. So that's all we need to graph. I could label the points that I've drawn in there. That would probably be good, but I've got my scale on the x-axis anyway, so that's all right. So that's all we need for example 5. In the next video, we'll have a look at example 6. Thanks for watching.